As you all know, I won't be in class today, but to help keep you on track, I'm going to provide you with a couple of videos to help walk you through the next couple of lessons. The first lesson is on solving basic trig equations, and we'll just be putting together what you already know about solving equations and what you've already learned about using inverse trig functions to find missing angle measures. You'll notice in the first examples, it's asking you to solve the following equations to the nearest tenth of a degree over the domain from 0 to 360 degrees. So you're going to need your calculator, and you need to make sure that it's in degree mode. And then to solve the first example, we want to try and isolate the variable, so we're going to subtract 9 from both sides to start. We'll get 3 cosine of theta is equal to -2. When we divide by 3, we'll get the cosine of theta is equal to -2/3. And to get rid of the trig function, we'll take the inverse cosine of both sides, which means we're left with theta equals the inverse cosine of -2/3. Remember that these two things are asking you the same question. They're asking you, at what angle is the cosine equal to -2/3? We know that 2/3 doesn't come off the unit circle, which is why we're going to use our calculators. But we do know that the cosine is negative in quadrant 2 and quadrant 3. And because it's little cosine, we want all of the answers. However, we are restricting to the domain of 0 to 360 degrees. So you're going to plug in your calculator, inverse cosine, -2/3, and when you do that, you're going to get a theta equal to 131.8 degrees. What you need to remember is that your calculator will only give you the principal value, meaning it's only going to give you the value like it's a big C cosine problem. So from here, we need to find out what alpha is so that we can find out what the angle is in quadrant 3. So if theta is 131.8 degrees, alpha is going to be 48.2 degrees. So if I add that now to 180 degrees, I find out that the angle measure that I'm looking for in quadrant 3 is 228.2 degrees. If we wanted all of the values for where cosine theta is equal to -2/3, remember at this point we would have to add 360n to each one of those theta values. But because the problem is restricting us from 0 to 360 degrees, those are the only two solutions that we're concerned about. I want to take a minute here just to reiterate that your calculator will only give you the principal value of the trig function. So it's only going to give you an angle measure from cosine between 0 and 180 degrees. It's only going to give you a value for sine between -90 and 90 degrees. And it's only going to give you a tangent value from -90 to 90 degrees. Okay, so let's see if we can solve some more of these equations. If I subtract 1 from both sides, I have 2 tangent theta equals -1. When I divide by 2, I have the tangent of theta is equal to -1/2. And when I take the inverse tangent of both sides, I get theta is equal to the inverse tangent of -1/2. Again, that question is asking you, at what angle is the tangent -1/2? And again, that's not something that comes off the unit circle. So we're going to use our calculator again. What we do know is the tangent is negative in quadrants 2 and 4. So when you plug the inverse tangent of negative 1/2 into your calculator, it'll give you a value between negative 90 and 90. You should get negative 26.6 degrees. That means alpha is 26.6 degrees, because if we're restricted between 0 and 360 degrees, in the second quadrant, if I subtract 26.6 from 180, one of my values will be theta equals 153.4 degrees. And if I subtract 26.6 from 360 degrees, I'll get theta equals 333.4 degrees. That's my angle measure in quadrant 4. And again, because we're restricted to 0 to 360 degrees, instead of adding 360n to both of those values, those are the only two that we're concerned about. Okay, so the next examples are asking us to solve the equations between 0 and 2 pi and round to the 3 decimal places, which means now we need to switch our calculators into radian mode. And to isolate the variable, I'm just going to take the inverse sine of both sides. So I'll get x equals the inverse sine of 0.6. In radian mode, right, on our calculators, we know that the sine is positive in quadrant 1 and quadrant 2. If I plug inverse sine of 0.6 into my calculator, I should get a value between negative pi over 2 and pi over 2. So in decimal format, you should get x equals 0.644, rounded to 3 decimal places. That's my answer in quadrant 1. So I need to subtract that from pi to get the angle measure in quadrant 2. So if I subtract 0.644 from pi, the other solution I should get would be 2.498. And again, because we're restricting between 0 and 2 pi, I won't add plus 2 pi n to those values because I'm only concerned about those two values, one that's in quadrant 1 and one that's in quadrant 2. For the next example, if I multiply both sides by 3, I'll get 5 cosecant x equals 27 over 4. And if I divide both sides by 5, I'll get cosecant of x equals 27 over 20. I know that the reciprocal function of cosecant is sine, so the sine of x is equal to 20 over 27. And if I take the inverse sine of both sides, then I'll have something that I can plug into my calculator, right? So x is equal to the inverse sine of 20 over 27. Again, in radian mode, and we know that the sine is positive in quadrant 1 and quadrant 2. When I plug that in my calculator, I should get a principal value of x equals 0.834, which is the angle measure in radians in quadrant 1. And if I subtract that from pi, the other solution I'm looking for is 2.307. And again, because of the restriction on the domain from 0 to 2 pi, Those are the only two solutions I'm concerned with. Okay, back to degree mode, but we probably won't need our calculators here because the first question is asking, when is the cosine of theta equal to 1/2? And we know that's in the first quadrant, right? Cosine is positive in the first quadrant and the fourth quadrant. The cosine of theta is equal to 1/2 at an alpha of 60 degrees. So in the first quadrant, theta will equal 60 degrees. And in the fourth quadrant, I subtract 60 from 360. The other solution is 300 degrees. Right? Remember, our restriction is from 0 to 360. So I don't need those plus 360 ends. In the next example, we just have to remember that when we take the square root of both sides, right, this says, what is the cosecant of theta squared? If I use that like in parentheses, squared. This is just another way to write that. So I need to take the square root of both sides. So I'll take the square root of the cosecant squared of theta, and I'll take the square root of 4. But remember, when I take the square root of both sides, I get two solutions. So when I take the square root of the left-hand side, I'll get the cosecant of theta, and when I take the square root of the right-hand side, I'll get plus or minus 2. But again, I know the reciprocal function of cosecant is sine, so sine of theta is going to equal plus or minus 1/2. The sine of theta is positive or negative in every single quadrant. Our alpha is 30 degrees. So in the first quadrant, I'll have theta equal 30 degrees. In the second quadrant, subtracting that from 180, I'll have 150 degrees. In the third quadrant, adding alpha to 180, I have 210 degrees. And in the fourth quadrant, subtracting 30 from 360, I have 330 degrees. Hopefully you're getting the hang of it at this point. So we're going to switch back to radians. We're going to restrict our domain from 0 to 2 pi. And we're going to look at the first one and say, when is the tangent equal to negative rad 3? Well, that's got to come from the coordinate point 1/2 rad 3 over 2 in some format, right? Which gives us an alpha of pi over 3. I know the tangent is negative in the second quadrant and the fourth quadrant. So with an alpha of pi over 3 in the second quadrant, x will be 2 pi over 3. And in the fourth quadrant, x will be 5 pi over 3. When is the secant of x equal to 1/2? Well, we know that the reciprocal function of secant is cosine, so the cosine of x equal 2. When does the cosine of x equal 2? Well, remember, cosine of x is restricted to being between -1 and 1. So when is the cosine of x going to equal 2? That's never, or no solution. With these last two, we might just have to do a little bit of digging to remember how to solve absolute value equations and logarithmic equations. For the absolute value equation, we just have to remember that we get two solutions. So if it's the absolute value of the cosecant of x is equal to rad 2, that means the secant of x is either equal to rad 2 or the secant of x is equal to negative rad 2. Reciprocal function of cosecant is cosine. So cosine of x is equal to 1 over rad 2. No rads in the denominator gets me the cosine of x is equal to rad 2 over 2. And I know that happens, right? Cosine is positive in quadrant 1 and 4. I'm going to follow the same logic down the other side. So I have the reciprocal function. So cosine of x is equal to negative 1 over rad 2. No rads in the denominator gets me negative rad 2 over 2. The cosine is negative in quadrant 2 and quadrant 3. If the cosine of x is plus or minus rad 2 over 2, my alpha is pi over 4. So in quadrant 1, x is equal to pi over 4. In quadrant 4, x is equal to 7 pi over 4. And from the other side, cosine of x is equal to negative rad 2 over 2 in quadrant 2 at 3 pi over 4, and in quadrant 3 at 5 pi over 4. And just one more. Remember to change from logarithmic form to exponential form. I start with the base, I raise to the power, and make it equal to the argument. So 2 to the negative 1 is equal to the cosine of x. Or the cosine of x is equal to 1/2. Well, when is the cosine positive? That's in quadrant 1 and quadrant 4. When is it equal to 1/2? That's at an alpha of pi over 3. So in the first quadrant, x will equal pi over 3. And in the fourth quadrant, that will be 5 pi over 3.